Hi, my name is Aaron Brown, and I'm here to talk to you today about cloud resource management in your playground. As security practitioners and leaders, we all face the reality that we often function as overqualified cloud janitors. Let's shift that burden to operators and use automation to outsource our janitorial duties. Let's start with what is cloud resource management. Cloud resource management refers to the process of overseeing and controlling the allocation, deployment, and utilization of workloads and resources in the cloud. This includes managing assets like VMs, storage buckets and devices, and network appliances. Lifecycling is a critical aspect and should happen in an automated way, alerting resource owners to upcoming actions such as stoppage or deletion. And just to state it aloud, our goal as security practitioners and leaders is to enable our partners to innovate and ship, but securely. In this short talk, we'll be focusing on tooling and automation, but of course there are behavior elements that teams should be trained on as well. Remember, ultimately, it's about getting products into the hands of the end user. And in order to do that and get there, your engineering teams need a playground. If you don't have a staging or development environment that allows your engineering partners to experiment, then stop what you're doing and do it now. It is crucial for engineering teams to have the space to explore and fail. Without it, your production environment will become cluttered, hard to maintain, and expansive in its attack surface. Do you and your engineering teams the favor of having an isolated playground in which they can make mistakes. Cloud environments and advancements in generative AI have significantly streamlined the process of deploying resources, enabling faster and more efficient operations. How can we ensure these resources are being spun up in a way that allows and enables for timely life cycling? No security practitioner or platform team wants to be a janitor. So let's automate it, while also enabling and even advocating for fostering innovation through exploration. The pursuit of solutions that allow for effective resource management is critical. This is because we are able to achieve two means: cost optimization and an enhanced security posture. I think most of us are well equipped and experienced enough to know why it's important that we maintain a hygienic cloud estate. A cluttered environment is an expensive one. The best way to win friends within your finance organization is to help reduce costs. I was at a place once where getting appropriate life cycling policies in place saved us over 6 figures in cloud cost. That's a tremendous amount of savings that can go back not only to your team, but also into the business in totality. A hygienic environment is a more secure one. The less you have running or stored in your environments, the less you have to worry about. I can say with confidence that all of us who've been in security for any length of time have dealt with the situation where a long-forgotten server in some environment seemingly far, far away from production was somehow able to wreak havoc in places it shouldn't have been able to ever touch. Rapid deployment. As we use IAC, so infrastructure as code, and PAC, policy as code, we accelerate development and set up guardrails. Infrastructure as code represents a widely adopted approach for deploying infrastructure, ensuring deterministic and standardized, auditable code that allows for peer review throughout the SDLC. Still popular, but perhaps less well known, is policy as code. This allows for security organizations and engineering teams to ensure that the infrastructure that they're shipping out aligns to their best practices and the controls within their environment. It helps establish the ability to ship an infrastructure that you can more easily clean up, that's more efficient, and more aligned to the goals of what you are deploying into your environment. By leveraging code to define policies, organizations can use this to achieve more consistent, more scalable, and transparent security practices. Some IAC and PAC products can be cost prohibitive to smaller organizations. This is where open source comes to save the day. Pulumi is an open source IAC and PAC that allows you to write in the language of your choice and deploy to any cloud. Development is fast, and PAC comes baked in. Here's an example of a Pulumi policy pack, requiring no public reads on buckets. Even in a staging environment, this is best practice. The code is straightforward, it promotes modularity, and again, it can be written in any language. This is a great example of a control that ensures we're limiting access to resources that should never be available publicly. What kind of policies can and should we create that enable life cycling and the ability to quickly spin up and spin down environments? Requiring resources to be created with tags ensures that you're giving your engineers the flexibility to choose their own adventure. To tie the resource back to the owner and team and TTL really gives you all the information you need. So why TTL? Why not just lifecycle after a static period of, say, 6, 8, or 24 hours? Some workloads need more time. Some workloads need to persist longer in your environment to enable teams to experiment longer and possibly push in different changes along the way with their testing. So having a TTL that engineers can set for themselves allows for additional flexibility that you want to provide for, while still, of course, keeping your environment clean. So here's an example of a Pulumi policy pack that requires the existence of certain tags. Similar to the public read on buckets, minus the metadata, it's just a few lines of code. It's powerful that we can create and tear down resources and set policies with just a few lines of a language that we're familiar with. Humans are bad cloud janitors. Not because we're bad people or we're bad at what we do, but things slip through the cracks. And oftentimes we're not able to move as fast as those who are shipping infrastructure out. Especially as we discussed earlier, with infrastructure as code and Gen AI, it makes it very easy to spin up workloads. On top of that, time and resourcing is scarce. And if you're working in a startup, we're all wearing many different hats and responding to many various needs across the organization. And if those two reasons weren't enough, it's just more cost-effective to rely on an operator to handle the janitorial tasks. AWS Nuke is a longtime favorite of mine, and it's been in the realm of cloud lifecycling and maintenance for a while now. It's as destructive as it sounds, and it's just as fun to use, but you still have to run it from your local machine. You can run it in parallel, and you can tear down the largest environments in no time. Risotto is a library offered by the good folks over at Some Engineering, and it's a stateful workload that requires an always-on machine to aggregate your environment, providing an interface to clean out the resources, and not surprisingly, the team calls these, the automation that you can bake in, jobs. If we're running AWS Nuke from our local machines, we're still just performing the cleanup ourselves. It just makes it a little bit easier than us writing all the scripts or clicking through an interface. Instead, let's shift the onus back into the cloud and make use of serverless functions. That way, it will issue commands on our behalf, and we don't have to think about it. Performing this in depth is an entire talk in and of itself, so let's stay high level. We're going to create a Lambda, which aggregates all resources outside TTL or outside compliance. For example, there's no tag associated to the resource. Then we trigger the AWS Nuke step function that will actually perform the deletion operation. And finally, provide a callback that gives us the ability to tie it into Slack notifications, especially if we want to provide context to owners that their resources are going to be deleted. This is especially nice if you want to continue partnering with engineering and set policies and allow them to get insight into what's going to happen with their workloads in advance. So what we'll do here is we'll use Pulumi again. We'll create the lifecycling mechanism using serverless functions, and we'll simply trigger the AWS Nuke step function. If we want to trigger off TTL, which of course we do, we'll need to get the current date time. That's not a problem. Again, we can write this in any language. Then we'll invoke AWS Nuke with our filtered list of resources to delete, and then we'll handle the process in the callback. So that way we can get assurance and proper error handling in place that it's actually taking the action that we need it to. Here, we're using the AWS nuke step function. This allows us to create a state machine, which will generate the callback. It will invoke our lambdas along the way, providing us everything that we need to keep our cloud environment clean, secure, and able to live another day. Risotto provides a stateful workload, which you can either run locally or you deploy within your cloud environment. It provides a user interface to search your inventory, set up jobs, and execute deletion. It's an all-in-one tool that allows powerful actions to be taken and set it up on an automated schedule. Self-hosting is straightforward, and keeping it running adds a bit of overhead, but it's worth it. I'm a big believer that repetition equates to execution. So one more time, by creating development environments in our clouds, we can employ mechanisms to enable innovation, while at the same time doing so in a secure, maintainable way. Thank you for your time, and I hope this helps set you on a trajectory to keep a cleaner, safer, more cost-effective development environment that we can all play in, and that we can all ensure that we're innovating, creating, and keeping it secure along the way.